Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at solving quadratic inequalities. This is part 9, and I encourage you to check out all the other videos prior to this part. And I encourage you once again to subscribe so that you don't miss out on any of our future uploads, be it on the quadratics list or any other topic that might be of interest to you, all on Numbers Simplified. Example 1. Solve 1 minus 3x times 2x plus 1 is less than 0. The solution. Consider the equation 1 minus 3x times 2x plus 1 is equals to 0. Take note, we made the sign to be equal in this case because we are going to consider the equation first, then analyze the inequality later on. From the quadratic equation videos that we have uploaded, you would know that we can get the x-intercepts that are given by setting the factors 1 minus 3x times 2x plus 1 is equals to 0. We separate this to have 1 minus 3x is equals to 0 or 2x plus 1 is equals to 0. We solve for x to get x is equals to 1/3 or x is equals to minus a half. To get the nature of the vertex, we expand the equation. So upon expanding it, we are going to get minus 6x squared minus x plus 1. And since the a is less than 0, the curve has got a maximum vertex. And note, there is no need to get the vertex point. Now, we see that the graph will be of this nature here. And analyzing the graph that we have, from the x-axis going upwards, the values are greater than 0 in terms of y, and for the x-axis and below for the curve, on the green side where we have the less than 0 on the left hand side and the less than on the right hand side, these are areas the graph is negative in terms of y. But according to the question, the graph has its part, y greater than 0 and y less than 0. According to the question, we want for y is less than 0. So we take the values of x that ensure that y is less than 0. Now take a look at this. From the values starting from minus a half going to the far left, the curve is negative, so we take that. And also for values that are from 1/3 and to the far right, the curve is less than 0. But for the values in between minus half and 1/3, the curve is above the x-axis. So this is positive greater than 0, which is what we are not looking for. Therefore, our solutions become x is less than minus a half or x is greater than 1/3. Example 2. Solve x squared plus 6x minus 7 is less than 0. The solution. We consider the equation. So remember, we drop the inequality and place an equal to so that we get that when factorized, x plus 7 times x minus 1 is equals to 0. That's from the quadratic factorization video. Then the x-intercepts are given by x plus 7 is equals to 0 or x minus 1 is equals to 0, implying that x is equals to minus 7 or x is equals to 1. And since the a is greater than 0, the a is the coefficient of x squared, by the way, the nature of the vertex is a minimum point, so that we have a curve of that particular nature. So for values that are between minus 7 and positive 1, the curve has got values that are less than 0 in terms of the y, and for values that are less than minus 7, the curve has got positive values on the y, as well as for x is 1 and beyond, we have the y values of the curve being greater than 0. So for that reason, we are going to settle for values that are at the far end less than 7 and values that are more than 1, because at these points the graph is more than 0, and that is what we're looking for. So our answer becomes x is less than minus 7 or x is greater than 1. Let's take a look at example 3. Solve x minus 2 squared is less than 14 minus x. The solution. We consider moving what is on the right hand side of the inequality to the left hand side, so that we have x squared minus 3x minus 10 is less than 0. So as we can see over here, since our a is greater than 0, the vertex should be a minimum point. And of course, from the quadratic factorization, we are going to have x minus 5 times x plus 2 is less than 0. Then for the x-intercepts, we are going to get x minus 5 is equal to 0 plus x plus 2 is equal to 0, so that we have x is equals to 5 or x is equals to minus 2 as our intercepts. Then our graph will be of that nature over here. So for values that are less than minus 2, the curve has got positive values, and for values that are more than 5, the curve has got positive values as well. Meaning that in between minus 2 and 5, we are going to get values that are less than 0. Therefore, y is f of x less than 0. That is what we were looking for. So that happens when we have values that are from minus 2 to positive 5, and that will be our solution. Example 4. Find the set of values of x for which x squared plus x minus 2 is greater than 0 and x squared minus 2x minus 3 is greater or equal to 0. So we've got a combination of the quadratic inequalities, the solution. We consider the equation x squared plus x minus 2 is equal to 0. So we consider the first inequality over here, so that we get some certain properties or certain things about this particular equation. So factorizing, we would get x plus 2 times x minus 1 is equal to 0, so that our a is greater than 0. Therefore, the vertex is a minimum point. We know that already, so that we have the curve of that particular nature. And we see that for values that are in between minus 2 and 1, the curve is less than 0. Otherwise, it's positive. So implying that, therefore, we are going to have x is less than minus 2 or x is greater than 1. Great. We also consider the second inequality, x squared minus 2x minus 3. Now we set that to 0, so that when we factorize, we get x minus 3 times x plus 1 is equal to 0, implying that x minus 3 is equal to 0 or x plus 1 is equal to 0. That would then imply that x is equal to 3 or x is equal to minus 1. So since our a is greater than 0, therefore the vertex is a minimum point, so that when we sketch our graph, we are going to have a graph of that nature, so that for values that are in between minus 1 and positive 3 are negative and positive otherwise. Now, since y is greater or equal to 0, then it means that the solution for this particular inequality, one of it, is x is less than minus 2 or x is greater or equal to 3. Right, so let's consider the two scenarios now. So we've got the first inequality and the second inequality that we were given in the question. So we want to eliminate the redundant solutions. So let's consider x is less than minus 2 from the first inequality, and the x is less than or equal to minus 2 in the second inequality. One of the two is strict and the other one is lenient. So we want to sort of eliminate the one that is too lenient, because it's only useful for one inequality. We want one that works for both, and it has to be the stricter one. We also consider the x is greater than 1 and the x is greater or equal to 3. So in the second bit, we see that for x is greater than 1, it's only useful for one inequality. It cannot satisfy the other one because the other one starts from 3. So what we have being common are values that are from 3 onwards. So we eliminate the x is greater than 1. The same goes for x is less than or equal to minus 2, because the other one only takes values that are more than, or rather less than, minus 2, whereas the equal to takes even the equal to minus 2. It's not strict enough. So we eliminate this because they are not strict enough to satisfy all the conditions. Therefore, our final solution for both inequalities becomes x is less than minus 2 or x is greater or equal to 3. If you've made it thus far into the video, I say congratulations, and I'll leave you with the following task. Solve x minus 3 divided by x plus 4 is greater or equal to x plus 2 divided by x minus 5. Remember, your experience in our sessions, your preferred future topics, your questions, concerns, and suggestions are always welcome in this channel. Make sure you write down such in the comment section. Remember to subscribe, like, and share the video so that you don't miss out on any of our future uploads. Thanks for watching Numbers Simplified. God loves you.